Hi everyone. Today I'm going to be talking about comparing linear functions, specifically comparing the slopes and y-intercepts of linear functions. So first of all, what is a linear function? A linear function is of the form y equals mx plus b in equation form. Graphically speaking, that means we have a line, a straight line graphically. And so here we're given two functions, function A and function B. Function A is given to us as a graph. Function B is given to us as an equation. And the question asks us which statement is true. The slope of function A is greater or less than the slope of function B. So let's recall how to find the slope of a function given a graph. So the first function is just graphically, and we take a clean point. I'm going to take one over here, and that is 2 comma 3. Okay, and I'm gonna go do rise over run. So I'm gonna go 1 2 3 ups and then 1 over. So rise over run, I rise 3 spaces, 1 2 3, and I go over 1. So our slope is 1. That's one way to find slope. The other way to find slope is to find 2 points on the graph. So this other point here would be 3 comma 6. And recall the formula to find slope. It's y2 minus y1 over x2 minus x1. And again, both of these equations are on your GED formula sheet. Okay? So you'll always have that with you when you take the GED. So I'm gonna call this point up here, the one top up here, call it point 2, and call this point down here point 1. Okay? So y2, the y coordinate of that second point is 6, minus 3, the y coordinate of the first point, over the x coordinate of the second point, which is 3, which is 3, minus 2, and we get 3 over 1, which is just 3. So that is our slope for function A. So slope of function A is 3. Okay. Now let's look at function B. Well, recall that the number in front of the x, okay, that represents our slope. So in this case, the number in front of the x, it's 2. Okay, the function B is already given to us in slope-intercept form. Okay, so the slope is just 2 for function B. Okay, and so we notice that the slope for function A is 3, which then that's greater than the slope of function B, which is 2. So this is our solution. Here's another problem. For function A, we're given an equation, and for function B, we're given a graph. Again, whenever you see slope or line-related stuff, you want to think y equals mx plus b. Okay? So for function A, in front of the x, there's really a hidden 1 here, and that just happens to be our slope, our m. So our slope for function A is just 1. Okay? Now let's look at function B. Well, I see a point over here. I see a clean point over here that seems to be 0, comma 1. And there's another point here, which is 1, comma 3. Okay? Again, you could do it graphically. I rise up 2, and I go over 1. Okay? Rise over run, or using the formula, y2 minus y 1 over x2 over x1. So we rise by 2 and we went over 1. So our slope for function b is 2. Let's check it out by using this formula here. Okay. Let's call this point 2 and this bottom point, point 1. Okay. So y2 is 3, y1 is minus 1 over x2 is 1, x1 is 0, and indeed we get 2 over 1. So we got the same slope either way. And so function a has a slope of 1, which is less than the slope of function b, which has a slope of 2. And I also want to say that sometimes you might be given a table of values, like a table of x and y values, for example, and you might be given points. So like 3, 5, 4, 8, 5, 11, for example. And you would just take 2 of the 3 points, any 2 of the 3 points. Maybe this might be my point number 2, and this might be my point number 1. And I would use the slope formula, y2 minus y1 over x2 minus x1. And you would use their x and y values to calculate the slope. Okay? Okay. So now we're given two linear functions, and one of them is in equation form and the other one graphically. And now they're asking us to compare the y-intercept of function A in comparison to function B. So recall the formula, the slope-intercept formula, y equals mx plus b. Okay? And recall that the number in front of the x, that is your slope. And the b, that is your y-intercept. Okay? And so looking at our function a, right, we have a slope of 1 and a y-intercept of 4. Okay, so I'm going to keep note of the y-intercept, okay, because that's what we're interested in. And for function b, well, the y-intercept is just where the line crosses this vertical y-axis, okay? And so it looks like they meet about here, and that's about positive 5. And so we have a y-intercept of positive 5 for function b, okay? And so it looks like the y-intercept of function a, which happens to be 4, is less than the y-intercept of function b, which is 5. So it'll be down here, be this option here. Here's another problem. Here for function a, again, we're going to look at our vertical y-axis here, and we're going to see where the line crosses this vertical y-axis. And it seems like it crosses at 3 here. So our b here is 3. Okay? And for function b, again, we're going to think back to our slope-intercept form. Y equals mx plus b. And it looks like the number in front of our x is 2. So our slope is 2. But we're interested in the y-intercept. Okay? And our y-intercept here would be negative 3. And so the slope-intercept of function a, which happens to be 3, is greater than our slope-intercept for function b, which is negative 3. So this is our solution. Let's do one more problem together. Again, for function a, we're going to look at our vertical y-axis here. And we're going to see that the line crosses around negative 1. So our y-intercept here is negative 1. Now, again, for function b, let's think about our slope-intercept form. Y equals mx plus b. Again, the number in front of the x, which happens to be 5, is our slope. Okay? But we're interested in the y-intercept. There's really a hidden plus 0 here. Okay, it's kind of hard to see. So our y-intercept really here of this form is just 0. And so the y-intercept of function a, which happens to be -1, is less than the y-intercept of function b, which happens to be 0. So this is our solution.